All right, welcome to the very first section, Networking 101. And I know what you're thinking. Hold on a minute. This is supposed to be a cybersecurity course. Why am I learning about networking? Well, to become a cybersecurity specialist or to understand lots of the concepts we'll be talking about in this course, you do need to have a foundational knowledge of networking. So that's why in this section, we'll be talking about things like MAC addresses, IP addresses, routers, hubs, the Internet Protocol suite, and the DNS system. Now, if you're already familiar with these topics, feel free to skip this section and jump on to the very next section. If you're not familiar with them, then I'll advise you sit back, relax, enjoy this section. But before you make up your mind, let's meet one man who has influenced the world of cybersecurity like no other.
About MAC addresses and IP addresses. Now, I'm pretty sure you've heard of an IP address before. Every time you browse or you try to connect to the internet, you would always need to use an IP address. So I'm sure you've heard of IP addresses, but what about a MAC address? You may or may not have heard of one, but let's jump right into it by first talking about the IP address. Now, IP, if you've ever wondered what that is, it stands for Internet Protocol. And all you need to know here is that the Internet Protocol is basically a set of laws that govern how computers browse on the internet. Now, this is a very layman, very basic explanation of the whole concept, but that's all you really need to know about the Internet Protocol. Now, an IP address is assigned whenever a device joins a network to make that device traceable. So whenever you connect your laptop or your mobile device to the internet, your device will be assigned an IP address. And the whole idea here is just to make sure that your device can be traced. That, oh, okay, this person is browsing from the United States, it's browsing from Germany. It is the IP address that will be used to track and trace your computer, your device, whichever one you're using to connect to the internet. Now, there are two types of IP addresses. You have the IP version 4 and you have the IP version 6. I will show you examples of that a little bit later. One very important thing you need to understand about IP addresses is that if you browse on the internet, okay, you're browsing and you're connected using a router, it is the IP address of your router that will be made visible to the internet. So whenever anyone is trying to trace you, they will find the IP address of your router. It will not be the IP address of your own device itself. Because what happens here is that whenever you connect via a router, your router will provide you with a private IP address. That's basically how it works. So the IP address of the router will be the one visible to the internet, while your own IP address of your computer or your mobile device, your laptop, whatever it is you're using to browse, will be assigned a private IP address by the router. And of course, if you're directly connected to the internet, well, it is the IP address of your own computer that will be made visible to the internet. So basically, whenever you browse, you want to go through a router. It provides an extra layer of security. That's kind of like the whole idea behind using routers for protection. Now, MAC address. First things first, what exactly is MAC? Well, that stands for Machine Access Control. Sounds very robotic, I know. There is nothing sexy about a MAC address. They're basically unique serial numbers assigned to every network adapter when manufactured. So unlike IP addresses that can be changed depending on the network or when the device joins the internet, MAC addresses are assigned whenever that network adapter is built. These are physical numbers assigned to network adapters, and they're meant to be unique. Okay. Now, MAC addresses are typically used to direct traffic or direct data from one device to the next as data travels on a network. That's all basically MAC addresses are used for. They're basically used to track different devices on a local area network so that the network knows that, okay, this particular data is meant for computer A, this one is meant for computer B, by simply using their MAC addresses. We'll talk about this a bit more when we talk about switches and routers. Now, finally, a MAC address cannot be hidden. Okay. IP addresses can be hidden by using VPNs, and we'll talk about this a bit later. But the MAC address, you can't really hide the MAC address. But the thing about the MAC address is that they're not as important as IP addresses. IP addresses are far more important, and these are usually what hackers would go after. MAC addresses are kind of like, okay, well, it's good to protect the MAC addresses, but then you can't really hide them. But at the same time, MAC addresses don't travel beyond the local network. So the MAC address of your computer or your device is not really exposed to the internet, if you understand what I'm trying to say here. So MAC addresses, don't really bother about them. They're not too important. But then again, it's always nice to know what they are and how they differ from an IP address. All right, so before I round up this video, I want to show you how you can get the IP address of your device as well as the MAC address of your network adapters. Now, I'm on Windows 10. What you want to do right now is to press the Windows key and R. This will give you the run command, and I'm going to type in cmd, press enter. And from here right now, let me just go ahead and expand my command window. I'm going to type in the words ipconfig/all. Okay, press enter. And now what you're going to get here would be the IP addresses and the MAC addresses of all the network adapters on your computer. Right now, let me just show you what I have here first of all. Now over here, I do have, let me just scroll all the way up here. All right, what do we have? I have my Ethernet adapter Ethernet right here. This is the network adapter for my physical connection. If I was going to use a cable, you can see right now that I do have the physical address right here. That's the MAC address of my Ethernet adapter right now. You can see I don't have any IP version 4, IP version 6 because I am not using it to browse. But if I scroll all the way down here, where I have my wireless LAN adapter Wi-Fi, this is what I'm using right now to browse. You can see it's the Qualcomm Atheros QCA61X4A wireless network adapter. This is the physical address, the MAC address of my wireless adapter. And right now, you can see that I do have an IP version 6 because that's what I use for browsing. You can also see I do have the IP version 4 address as well. So this is the IP version 4 address assigned to me by my router. Okay, this is the local private IP address that I'm using right now for my adapter. And of course, if I scroll all the way down here as well, you can see I do have another one, the Ethernet adapter Bluetooth. And you can see this is the physical or the MAC address as well. So this is one way how you can find out the MAC addresses of all the network adapters you have. Keep in mind once again that your network adapters would be things like your Bluetooth adapter, your wireless adapter, your Ethernet adapter, and so on and so forth. All of them will have their own unique MAC addresses, and whichever one you're using to browse will have your IP version 4 as well as the IP version 6. You can see how the IP version 6 is different from the IP version 4. It's a lot more complicated, has a lot more digits than your IP version 4. So that's basically the MAC addresses and IP addresses in a nutshell. Thank you for watching, and of course, I will see you in the next class. And here we are going to talk about hubs, switches, and routers. Now, I'm pretty sure you've heard of the term router before. I'm most positive about that. You may have heard of a switch before, but a hub, you may or may not have heard of a hub before. But basically, all these are used for connecting devices and networks together. They're basically networking equipment. That's all they are, really. Now, they of course have ports for wires that do the physical connection. So typically, you would connect one end of a cable to a hub, and then the other end would go to the device, whether it's a laptop, a server, what have you. And of course, we have switches and routers that also have wireless connectivity as well. Now, what exactly is the difference between these devices, right? It's their intelligence levels. It is their intelligence levels that is the chief difference between these three devices. All right, so what I want to do right here is to give you an example of how hubs, switches, and routers would work on a network. Now, over here, you can see we have a hub, and then we have three devices, A, B, and C on the local network. Now, imagine a message came in for computer A, and it passes through the hub. Now, you'd think to yourself, well, the hub will just simply take the message and give it to device A. Unfortunately, hubs are kind of stupid. They're not intelligent at all. So what they're going to do instead would be to give that message to every single device on that local area network, because the hub doesn't know which one is device A. All it says is several devices connected to it. That's all it knows. So in order for the hub to guarantee that the message will get to the device A, it will send out the message to every single device on that network. So basically, this results in very heavy performance issues. Performance is degraded because what happens is you have systems such as system B or system C right here on the diagram. They end up receiving messages not meant for them. So basically, the hub disturbs them, saying, "Hey, device B or whatever you are, is this message meant for you?" And then device B has to say, "No, it's not for me. It's for device A. You're such an idiot. I'm device B." And the hub will be like, "Okay, I'm sorry. Well, I don't know, what your name is. I'm just sending out the messages. Okay, don't hate the messenger, hate the message." That's basically what the hub will tell all the devices connected to it. But basically, that's how the hub operates. It doesn't know what devices are connected to it. It simply takes a message and then broadcasts that message to every single device on its own network. Now, let's compare this with a switch router. Now, these are far more intelligent, they're far more advanced than a hub. So, in the same scenario, if a message comes in for system A or device A, the switch or the router would know that, okay, this message is actually meant for device A. So I'm going to go ahead and give that message to device A. So what you have here is you have much more improved performance. Efficiency is increased because right now systems that aren't meant to receive messages would not receive those messages. It's only devices or systems that have a message for them. Those are the ones that will end up receiving that message. So overall, switches and routers are far more intelligent. They're far more effective than hubs. Hubs are just stupid, basically. All right, so now that you've seen the major difference between hubs and switches and routers, let me now try and differentiate between switches and routers. What are the core differences between these two devices? Well, a switch is basically used for transmitting data or information among devices on a local network, while a router is used for routing data among networks. So basically, the router is used for connecting networks together. Think of it that way, while a switch is used for connecting devices inside of a network together. That's basically the core difference here. The second one here is that switches use MAC addresses while routers use IP addresses. So that's another core difference between the two. Switches will use MAC addresses to do their switching. Routers will use IP addresses for their routing. And finally, which is of course the main difference here, routers are far more powerful and they provide additional features such as firewall protection as an example. A switch is just a very intelligent hub. A switch will help you transmit data between devices on a network, but that's about what a switch can do. Routers, on the other hand, are far more powerful and can do so much more. So these are the differences between switches and routers, and I hope overall you now understand the core differences between hubs and switches and routers and what exactly they are used for. Thank you for watching. Let's jump on to the very next class. Not internet, but Ethernet. And you might have heard of this term before, but what is it and what does it do? Well, Ethernet is the protocol that determines how data is transmitted in a local area network. It's also technically referred to as IEEE 802.3 protocol. So if you want to impress your friends or your family, rather than say Ethernet, just say IEEE 802.3 protocol and they'll think you're some sort of genius. All right, so they are used widely in offices, banks, and in homes. So whenever you walk into an office where you have computers connected to one another through maybe a switch, and then you also have printers which the computers can use, that's basically a local area network. Now you have a wide area network which is much bigger. In this case, you might be talking about connecting the network of one building in one part of the city to another building that's just around the same place in that same city. All right, that's basically what a wide area network is. A local area network is a lot smaller than a wide area network. All right, so most laptops and PCs do come with integrated Ethernet cards. If you have a PC or a laptop, you very likely have an Ethernet card inside of it. So what are the network requirements for Ethernet? Well, you need computers and devices like a printer, computers. You need Ethernet cards and ports like your RJ45 port, hubs and switches, cables, obviously, and finally, you need a software to manage the network. So it's a very simple kind of network with all of these devices. So what is the process like? How does Ethernet actually work? So let's say, for example, device A wants to send data to device B. What it's going to do is it will check to see if the carrier, now the carrier in this case is the main wire connecting the devices. It's going to check if that carrier is free. If it's free, device A will send the data packet on the network, and obviously device B would receive the packet. Now, if no, device A would simply wait for some thousands of seconds before trying again to send the packet. So this is a very simplistic explanation of Ethernet in action. You can obviously go a lot deeper and a lot more technical, but for the purposes of this course, this is all you need to know about Ethernet. So thank you for watching. I'll see you in the next class. TCP, HTTPS, SSL, and TLS. So many acronyms, so little time. Oh boy. All right. HTTP. Well, this stands for the Hypertext Transfer Protocol. That's basically what HTTP stands for. It defines how messages are formatted and transmitted over the web. But not just that, it also determines what actions web servers and browsers should take in response to various commands. So HTTP basically is the mother of all protocols involved in the World Wide Web. It's basically behind every single request, how requests are handled between web browsers, web servers, and so on and so forth. Very, very important protocol. So how exactly does HTTP work? Well, the first thing you have to understand is that every web server has something called a daemon. The daemon is a program that is designed to wait specifically for HTTP requests and then handle them when they arrive. That's the job of the daemon. Now, your web browser, whether it's Firefox or Google Chrome or Safari, is what we call an HTTP client, and they make requests to the web servers on your behalf. All right. So when you enter the URL of a website, let's say, for example, www.sports.com, or you click on a hyperlink on the website, your browser will build an HTTP request and send it to the IP address indicated by the URL that you've added to the browser. All right. Now, the HTTP daemon in the destination server machine will receive your request and send back the requested file or files associated with your request. So that's basically how HTTP works in a nutshell. Now, HTTPS. It's Hypertext Transfer Protocol Secure. This is the secured version of HTTP. So basically, it's secured because communication between your web browser and the web server is encrypted. Very, very, very important. And this is a must for websites where sensitive information like passwords, credit card details are exchanged. Never ever provide your password or your credit card details on a site that doesn't have HTTPS. And I will show you in just a second how you can check to see whether or not a site has HTTPS running on it. Now, for HTTPS to work, encryption must be implemented, and it's implemented making use of TLS or SSL. That's how encryption is implemented in HTTPS. So, SSL, what is this? This stands for the Secure Sockets Layer, and it establishes an encrypted link between your web server and the browser. That's what it does. Now, your web server requires an SSL certificate to be installed on it. So if you have a website and you wanted to establish a secure link between your web server and any browser out there that wants to have any sort of access to your website, you need to install an SSL certificate, all right? This certificate will serve as proof that your website is secured with SSL, but it also has an expiry date. So anytime a browser from around the world tries to access your website, it will check to see if the certificate has expired before completing the connection. So if you have a website out there, it's very, very important that you have an SSL certificate. Having an SSL certificate will prove to the visitor on your website that, hey, my website is secure. Don't worry, you can provide me with passwords, credit card details. It's all encrypted. Now, TLS stands for the Transport Layer Security, and it's basically the successor to SSL. And being the successor, naturally, it's more advanced and offers higher degree of encryption and security. So SSL is becoming a bit more outdated. TLS is the new kid in town. Now, you should also know that SSL and TLS are used interchangeably. So don't be too confused when someone mentions SSL, when in fact they're referring to TLS. They're basically used interchangeably all the time. So I wanted to show you HTTPS in action as well as HTTP. So one very quick way how you can find out whether or not a website is secured with HTTPS is to pay attention to the status over here where you have secure with the green padlock. And you can see it's HTTPS. This is Amazon. So if I click on secure, it says your information, for example, passwords or credit card numbers, is private when sent to the site. So you can see this is the indication right here that HTTPS is active on Amazon.com. However, if I go to ABC News, shame on them. This is a major website and they still don't have HTTPS. If I click on the I button right here, okay, it says your connection to this site is not secure. You should not enter any sensitive information on this site because it could be stolen by attackers. So it's really mind-boggling how in 2018, there are still many major websites out there that haven't implemented HTTPS. It really is a shame. So if you have a website, I would strongly recommend that you get SSL. Not only does it provide security for your clients, but it actually helps with your boosting in the Google search engine. The Google search engine and other major search engines give you extra points when they know that you're running HTTPS on your website. That's a fact. Now, to get SSL certificates, usually most good web hosts out there will provide you with a free SSL certificate. I use SiteGround as an example. But if for some reason your web host doesn't provide free SSL certificates, you can go to let'sencrypt.org. This is one of the very best sites where you can get a free SSL certificate. Thank you for watching, and I'll see you in the next class. Topic in the world of the internet, and that is the Internet Protocol Suite. So what is this Internet Protocol Suite? Well, it is the conceptual model and set of communication protocols used on the internet. It provides end-to-end data communication specifying how data should be packetized, addressed, transmitted, routed, and received. So in other words, it is responsible for data, whether it's an image, an audio file, or a video file, sent from a host to a destination and vice versa. So whenever you go online and you upload a video file, or you download an audio file, or you send an email, basically anything you do on the internet, or whenever you communicate with another computer, maybe you send some files over your local area network to another computer, that entire process, the entire process of data leaving your computer, going to another computer, the entire process is covered by the Internet Protocol Suite. That's the best way to think about it, all right? Now, it is commonly referred to as TCP/IP, the two foundational protocols of the Internet Protocol Suite. TCP stands for Transmission Control Protocol. IP stands for the Internet Protocol. We'll talk about these two in just a minute. Now, TCP/IP is divided into four main layers. You have the link layer at the bottom, you have the internet layer, transport layer, and finally the application layer. These are the four main layers of your Internet Protocol Suite. Now, the link layer. It is the lowest layer in the TCP/IP architecture. Now, what you have here are communication protocols that only operate on the link that a host is physically connected to. So think about this for a minute. How is your computer connected? Is it connected via wireless, maybe? Is it connected with a cable? Maybe it's connected with an HDMI cable or some sort of Ethernet cable and so on and so forth. So the kinds of protocols you would find here include your MAC, your media access control, which remember is the number assigned to your network adapter, your physical network adapter. You have Ethernet as well. And then you have IEEE 802.11, which is the technical term for Wi-Fi. So these are the kind of protocols that exist at the link layer. Whatever protocols help to attach or link your computer to a network or another computer that is covered by the link layer. So next we have the internet layer. Now this handles internet talking between networks. So whenever you're transmitting information or data from one network to another, that's when the internet layer takes over. Now, contrary to popular belief, the internet layer is not responsible for a reliable transmission. You might think to yourself that, hey, okay, since I'm sending data from this network to another and the internet layer is responsible, shouldn't the internet layer account for a reliable transmission? The answer is no. And I'll tell you the layer that is responsible for this in just a minute. But what is the internet layer responsible for? Well, it captures data packets and sends them to the appropriate transport layer protocol. It also provides error detection and diagnostics. So whenever there is a problem transmitting or transferring data from one network to another, the internet layer is responsible for diagnosing what happened and provide analysis. Now, the sample protocols include your IP version 4 and IP version 6, and your ICMP, the Internet Control Message Protocol used for error detection. These are the two most popular protocols that exist in the internet layer. Next is going to be the transport layer, layer number 3. Now, this handles host-to-host communication. So from a computer to another computer, from a network to another network, this is the layer that handles such communication. Now, it is the transport layer that is responsible for reliable transmission. It's also responsible for flow control and prevents congestion, so that whenever you're transmitting data from one network to another, too much data isn't transmitted at once. It's basically the transport layer responsible for making sure that you don't have any congestion. Now, the core protocols in the transport layer are TCP, which we talked about, and UDP. These are the two main protocols that exist in the transport layer. Now, last but not least, we have the application layer. Now, this handles data exchange between applications. That's all this layer does. And of course, it makes use of specific protocols in the layers beneath them. So say, for example, your Gmail service, for example, operates in the application layer. FileZilla, which is a software for downloading files over the internet, can exist in the application layer, and so on and so forth. Your web browsers, all these exist in the application layer. So some protocols would include your HTTP, which is used by your web browsers. You have SSL for providing security as well. You have FTP for downloading files over the internet, and you also have SMTP, Simple Message Transmission Protocol, which is used for emails whenever you send emails over the internet. These are the kinds of protocols that exist in the application layer. Now, to round this up, I wanted to show you an image I got from Wikipedia. Here you have a network topology describing the internet protocol in action. So you have a host A, a computer A on the left, and then you have computer B on the right, and there are two routers in between them. So if host A wanted to send, let's say, an email, for example, to host B, first of all, host A needs to be connected to the internet, right? So first you have the link layer, which in this case will be Ethernet, connecting host A to the internet. Next, since host A is sending an email over the network, the internet layer comes into play, because now you're transferring information from a computer to another network, basically. Next will be the transport layer, responsible for the actual transmission of the data from host A to host B. And then finally, you have the application layer, Gmail in this case right now, being used to send the email from host A to host B. So this is kind of like an idea of how the Internet Protocol Suite works. Thank you so much for watching, and of course, I will see you in the next class. About one final topic, which is the almighty DNS system. And I'm pretty sure you might have heard of the term before, DNS. But what exactly is this DNS? Well, it stands for the Domain Name System. And it's responsible for translating domain names into IP addresses. So say, for example, you wanted to go to www.alex.com. DNS will translate www.alex.com into 101.43.192.45. What am I talking about here? Well, you see, web servers, web browsers, they don't understand names like alex.com, espn.com, cnn.com. They don't. All they understand are IP addresses. But now imagine if, rather than typing in the domain names, we had to type in the IP addresses of such websites. Just how difficult would that be for us? We'll have to start memorizing IP addresses instead of domain names. So what happens here is this: when you go to your web browser and you type in www.alex.com and you press enter, it is DNS that will translate that domain name into an IP address. That's the job of the DNS, and that's why it's so important. It's basically the phone book of the internet. That's basically what the DNS is. So the DNS delegates the responsibility of assigning domain names and mapping those names to internet resources by designating authoritative name servers for each domain. In other words, the domain name system isn't just one big central database that has all the list of the websites and their corresponding IP addresses. No, you have several servers, several DNS servers scattered all over the world that can help you map IP addresses to domain names. So of course, this helps to avoid having one large central database. Imagine if the DNS was just one database and it failed. We'll all be in trouble. We'll not be able to browse. So the DNS servers, they work in an hierarchical structure. Very, very important. Now, at the very top of this structure, we have something called the root name servers. These guys are extremely important. Now, they are responsible for returning a list of the authoritative name servers for each top level domain. Remember that every website you visit has either .com, .edu, .biz, .org, and so on and so forth. Each of those top level domains, .com, .edu, they have one major DNS server that has the list of all the websites and their IP addresses under that specific domain. All right. Now, they are also, that is the root name servers, they are also the first stop in resolving domain names into IP addresses. And every DNS server contains a list of the root servers. Now, I want to use this diagram to explain to you the entire concept of DNS and how it works. So step number one, let's say, for example, you're trying to access yourcompany.com. What's going to happen here is this, okay, you go to Firefox or Chrome, you type in yourcompany.com, you press enter. Your web browser is going to contact the DNS server for your ISP, asking, hey, can you help me find the IP address for yourcompany.com? If this is the first time you are accessing this website, it's possible that your ISP's DNS server will not know the IP address. So what's going to happen? Your ISP's DNS server is going to contact one of the root DNS servers. Remember that every single DNS server has a list of all the root DNS servers. So it's going to contact the root DNS server saying, hey, can you help me find the IP address for yourcompany.com? Now, the root DNS server isn't going to know the exact IP address for yourcompany.com. But do you know what the root DNS server knows? It knows the top level DNS server specifically for .com. And remember, the top level DNS servers for .com or .biz or .edu are going to have the entire list of all IP addresses and the domain names that correspond to those IP addresses under that specific domain. All right. So the root DNS server is going to say, hey, here is the contact information for the top level DNS server for .com. Ask him. I'm pretty sure he will know the IP address for yourcompany.com. So step number 5, your ISP's DNS server will now contact the top level DNS server for .com saying, hey, can you help me find the IP address for yourcompany.com?
And since this is the top level DNS server for .com, it's definitely going to have the IP address for your company.com. So the top level DNS server is going to say, okay, well, here's the IP address for your company.com. So your ISP's DNS server is going to say, thank you very much, I've gotten the IP address. Then your ISP's DNS server will now give the appropriate IP address back to your web browser saying, hey, here's the IP address for your company.com. And that's how you are able to access your company.com. Now that your ISP's DNS server knows the IP address for your company.com, it is going to cache that knowledge. It's going to cache that IP address. So the next time you're trying to access your company.com, rather than going through the entire process again, your ISP is simply going to check its cache table and see whether or not your company.com was accessed recently. Since it was accessed recently, your ISP's DNS server will say, oh, here's the IP address, and it's going to be a lot faster for you to access that website. That's why sometimes you may have noticed that when you visit the website for the very first time, it might take a while, but the next time you visit that website is going to be a lot faster, and that's because of what's just happened here as I explained it. So thank you for watching, and I will see you in the next section.